Alright, the last bit of this lecture is about t-testing. You will have heard a bit about t-testing already, and I'm going to walk you through an example using that forested area hypothesis. So what we do is we're going to set up this formal t-test. And there's a couple of steps in how to set up the test. First of all, we formulate the hypothesis. And a statistical way of presenting a null hypothesis is H0, and the hypothesis here is that the mean is 40. Our alternative hypothesis is that it's not 40. Then you have to decide on a alpha level, which is 0.05 in most cases. So that's the certainty that you have or have not rejected the null hypothesis correctly. And then we calculate the t-test statistic. The t-test statistic is calculated simply by taking the mean, subtracting our hypothesized value, and then dividing it by the standard error. So you can do this by hand. It's not that difficult. So take the sample mean, which was the sample mean in our example? It was 32.5. In our sample of global forest cover, the average was 32.5% forest cover. And we hypothesized that it would be 40%. Then we take that standard error. Now a standard error is the standard deviation divided by the number of observations routed. We had 201 observations in this data set, 201 countries, and we know that the standard deviation was 23.8, the standard deviation in all those observations. So when we calculate the standard error, it is about 1.7. We then calculate the test statistic, and that is 7.5 divided 1.7 is approximately minus 4.5. What does that mean? Is 4.5 an indication that it is significantly different, or that it's not significantly different? What we do is we compare this test value to a bunch of critical values that very clever people have come up with, and you can find those in all sorts of statistical tables. So what I typically do is I go to a test table. In this case it's a t-test, so we're looking for a t-table. And we find the critical value against which that test value is evaluated. Now I've copied a test table here. I am interested in, say I'm interested in a one-tail test or a two-tail test. If I'm looking at a two-tail test, I divide that alpha value by 2. And these are degrees of freedom. 1, 2, 3, 4, 5, 6. This is infinity. If your sample is large enough, you can just use the critical values for infinity. So degrees of freedom, we have 200 observations. Lots of degrees of freedom, we can just use that infinity. And then the critical value that our table gives us is 1.96 for a two-sided test. For an alpha level of 0.05 on one side, which means 0.025 on one side and 0.025 on the other side. The critical value is 1.96. I've shown that here in a bit of a graph, which may clarify it. What we're interested in is is 4.5 out of that certainty level of 95%. Now we've just seen that the critical value is 1.96 and 4.5 is much larger. It's larger than the critical value, which me as a statistician says that it's far enough from zero to reject that null hypothesis. Remember, the null hypothesis was that our sample mean was 40. Rejecting that null hypothesis means that our average forested area is not 40%. Our test value of 4.5 lies in the rejection region, the region of 0.05%. Now you're going to practice this t-test in the tutorials, and I highly recommend practicing them several times because the first time is always a bit confusing. Now, instead of doing it by hand, there's also plenty of statistical software you can use, and you use R in this unit. So with R, you can just say, right, we have forest data and we want to do a t-test. That mu is 40. Mu was that mean, the average. So you can see that on this screen. We use the forest data, we undertake a t-test, where the hypothesis is that we have an average of 40. It gives us a t-value about 4.5, number of degrees of freedom, and a p-value. So p-value is a certainty value, and we compare that to our alpha that we're interested in. So in our case, we said we accepted an alpha of 0.05, but the p-value here is smaller than at 0.05, and therefore we reject the null. We're not certain that that null hypothesis is actually true. So sample mean was 32.5. We hypothesized 40, and we find that it's not actually 40. The proportion of forest in the world is different from 40%. I'm saying different because I just did a two-sided t-test. Remember, I used the 0.025 value, where there was 0.025 on one side, 0.025 on the other side. Together, that makes an alpha of 0.05. You could also do a one-sided test to test whether the mean is actually less or more than 40%. And that would be a one-sided t-test. I don't have time to go into that in the lecture, but I'm sure you can find more information in James's lectures or in the tutorials. You can also get help using the R book that James is providing as a resource. So what do I want you to know about this whole lecture is biodiversity values, those use and non-use values. I want you to know that non-market valuation approaches exist to estimate those values. And I've shown you a way to test your data, either through visual inspection, so graphs, and t-testing. And practice with those t-tests because they will come back in some of the tests and the exam. So I'll leave it there, and I wish you a great weekend.